Hello and welcome back. In this video, we discuss about moment of a force couple. Let us review the concept moment again. The rotational effect of a force vector is quantified by moment vector. So in order to understand that, if we are acting a force at a point A on a rigid body whose position is R with respect to a reference point O, then moment vector is defined as m vector equals r cross f, where r is the position vector of the location A with respect to O, and f is the force acting on the body, where A is the location of point of application of the force. We have also seen that the moment vector is perpendicular to the position vector and the force vector. Depending on the orientation of R and F, we may get anti-clockwise moment and clockwise moment. So this is what we discussed in the previous lecture video. Now we will see what is a force couple. So force couple means we have two forces. One force is acting at point A on a rigid body, and another force is acting at B. So here uh, the second force is equal in magnitude, but the direction is opposite to the force F. So this means that we have two forces acting on an object at two different locations. When you add these two forces, the net force will be zero because one is opposite and equal to the other force. The net force will be zero. However, since these two forces are acting at a finite distance, this will create a rotating effect. We call this rotating effect of two forces which are separated, two equal forces which are separated at a distance, is called couple moment. I repeat, the rotational effect of two equal and opposite forces on a rigid body acting at a rigid body at two different locations creates a rotating effect, and that rotating effect is called couple moment. Also note that for couple forces like this, the net force will be zero. So we can expect only the rotational effect on this object because of this force configuration. Now we will derive an expression for couple moment. The object is acted by two equal and opposite force, F and minus F, as indicated at locations A and B. The position vector of point A with respect to a reference coordinate is RA, and the position vector of point B with respect to the same reference coordinate is RB. So we can see that RA minus RB is R, which is a position vector of A with respect to B. Now we will take moment of force, both forces, about O, which is MO vector equals, we need to do the R cross F for both the forces. So let us start with RB, which is the position vector of force minus F. So R cross F means RB cross minus F plus RA cross F, where RA is the position vector of the point of location where F is acting. Now, this will lead to MO, the moment vector, net moment, will be equal to RA minus RB cross F, a simple algebra. So which can be simplified further to R cross F. So the moment due to the coupled forces minus F and F is M vector is a couple moment equals R cross F. Remember, here the R vector is the position of one of the point of application of force from the other. It is, but the expression is similar to the definition we looked at earlier, which is moment of a force about a reference location O. So the couple moment is R cross F, where F is the force, one of the force, and R is the position vector of point of application of this force from the other location. Consider a problem that involves a couple of forces. A steering wheel is acted by two forces, 100 Newton in magnitude. So we need to find out, as indicated in the figure, so we need to find out the couple moment of this configuration. The forces are separated. The point of application of both the forces are separated by a distance of 5 meters in this case. And we fix a coordinate reference I, J, and K as indicated. So the definition of couple moment is R cross F. So the position vector of the force which we are considering is, which is 100 Newton acting in the upward direction. So the F we are considering is 100 J acting upward. So the position vector of the point of application of this force from O is 5 meters in the I direction. So the position vector is 5I. So the couple moment is R cross F. So we know, since we know both R and F, we use the determinant expansion of I, J, K vector and the first vector and the second vector. Using the method we discussed earlier, we get the couple moment as 500K. Remember, it is very straightforward, but the only thing is you need to figure out the force vector and the position vector of the point of application from the second point of application. So once you figure out R and F, the couple moment is very straightforward because it's just R cross F. We have another problem. Calculate the couple moment of forces acting on a lever as shown in this figure. The lever has 8-meter arm and 6-meter arm, which is 30 degrees to the horizontal plane. So we know that the couple moment equation is R cross F. Now we need to figure out the force vector and the position vector. Now we assume the force as 25 Newton, which is acting at B, as 25 K Newton. It is in the K direction. 25 Newton acting in the K direction. So with respect to A, the point B, we need to find out the position vector of uh, the position vector RAB. Given that it is 6 meters along AB, we need to resolve the 6 meters into I and K direction. So when we do that, we get 6 cos 30 in the I direction, and we get 6 sine 30 in the minus K direction. So we can write the position vector of B from the reference A, which is the point of application of the second force, is 6 cos 30I minus 6 sine 30K meters. And our force vector is 25 kN. So the couple moment is R cross F. We have the determinant IJK, then 5.2, which is 6 cos 30. 0 is because we don't have J component in that position vector, so that's 0. Then minus 3, which is 6 sine 30. And the force vector is 0, 0, 25, because the magnitude, the coefficient of I and J is 0 in case of force. So expanding this determinant, we get the moment vector as 129.9 J. It's minus, so it is clockwise direction as indicated. So clockwise direction is in the minus J direction. In this problem also, the couple moment is R cross F. From the given geometry, we selected one of the forces, and with respect to the point of application of that force, we figured out what is the position vector of point of application from the other point where the force is acting.